Hello everyone. In today's lecture, I will start from units of charge. This is our lecture number 3 of electrostatic series. Let's start. Okay. Let's start with our lecture number 3, that is from units of charge. Units of charge. So in SI system, what is the unit of charge? Its unit is coulomb. Okay. Let's prove it. Okay, the unit of force, the unit of force is Newton, and let's suppose this one is 9 into 10 to the power 9 Newton, say, and we have Q1 is equal to Q2 is equal to Q, say, and R is equal to the distance between two charges. Let's suppose 1 meter. Okay, I am taking everything in SI unit. Okay, and what we have the formula for force, that is, sorry, okay, the formula for force is F is equal to 9 into 10 to the power 9 Q1 Q2 divided by R square. I am talking about free space, that's why I have taken the value of 1 by 4 pi epsilon naught as 9 into 10 to the power 9. Okay, let's put the datas the datas in the above equation. Okay, but it will be 9 into 10 to the power 9 Newton is equal to 9 into 10 to the power 9 into q square divided by r square, means 1 rho square. So what it implies, q square 9 into 10 to the power 9 cancel out. It will left with what? It will left with your 1. Q square is equal to 1. That implies q is equal to plus minus 1 coulomb. Hope you understood how we derive the charge unit. Okay, so we can define 1 coulomb as how much. So definition of 1 coulomb, write it down, it may be important in some of your state exams. Okay, 1 coulomb is defined as the amount of charge which, when placed from a similar charge 1 meter apart. 1 meter apart means 1 meter distance. In 1 meter distance we have placed two similar charges, okay, apart, in free space. This one is very important term, that is free space. Will repel each other with a force of what is the magnitude of this force? With a force of 9 into 10 to the power 9 Newton. Okay, is it clear to everyone? Yes, hope it will be clear. So let's talk about CGS system. In CGS system, its unit is start coulomb. Start coulomb, or we can say it is the unit of ESU of charge. Okay, so in this system similar, I will make it so simple for you. In this system, for free space, for free space, what I have, F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square, 1 by epsilon. Okay, as I am talking about the CGS system, I can't take it as 9 into 10 to the power 9. So better if I will keep it as a constant and Q1 Q2 divided by R square. Let Q1 is equal to Q2 is equal to Q is equal to Q, and R is 1 centimeter as I have taken the CGS system of units, and F here is 1 die. Okay, and for free space the value of K is 1. So what will be its equations if I will keep the data in that equation? That will become 1 die is equal to 1 into q square divided by 1 centimeter square. That implies q square is equal to 1, q is equal to plus minus 1 start coulomb, plus minus 1 start coulomb. Okay, you can also define one start coulomb is defined as that amount of charge which when placed from a similar charge 1 centimeter apart in free space will repel with a force of 1 die. Similar to the how I defined 1 coulomb, you can define also one start coulomb, but here the distance is 1 centimeter and the force will be 1 die. There the force will be 9 into 10 to the power 9 Newton. Okay. So another CGS system, in CGS system there is another unit that is amp coulomb, that is EMU of charge. We named start coulomb as ESU of charge and we named this as EMU of charge, that is amp coulomb. How we defined it? Similarly, we know that force in a moving charge moving charge in a magnetic field in a magnetic field is F is equal to QVB sin theta or QB cross B, isn't it? Where B is magnetic field intensity and V is your velocity. So if I will take the magnitude only, then it will become BQV sine angle between them theta. Q becomes F divided by BV sin theta, isn't it? So I can define one half coulomb as so 1 half coulomb as 1 Newton divided by unit of V is Gauss in CGS, Gauss into V velocity 1 centimeter per second because I am taking the CGS units, and sine 90, the maximum value of sine. You can define, sorry, okay, it's fine now. This is one die, okay, one die. You can define 1 half coulomb as the amount of charge which when moves with a speed of 1 centimeter per second at right angles to a magnetic field of strength 1 Gauss experiences force of 1 die. Okay, is it clear? Yes, it is clear to you now. I will move forward. It's a very important point, that is relation between coulomb and start coulomb. What is relation between coulomb and start, sorry, sorry. Okay, where we are, relation between coulomb and start coulomb and start. I am doing the derivation for you also. You don't have to worry about it. Okay. Sometimes it acts as a 3 marks or 4 marks questions. Like so, start the derivation. Let 1 coulomb is equal to x start coulomb. Okay. Let's suppose we have two charges of 1 coulomb each magnitude, and they are separated by a distance of 1 meter. They are separated by a distance of 1 meter in free space. Remember, we are always doing the free space for simple cases. Okay. So what is the force between the two charges then? F is equal to 1 by 4 pi epsilon naught q1 q2 divided by r square. This will become 9 into 10 to the power 9, as we are talking about the free space and the magnitude of charge is 1 and 1, and we have 1 meter square, 1 square. It will become 9 into 10 to the power 9 Newton. Okay. Okay, sorry for the interference. Okay, so let's start with our calculation where we were. Okay, F is equal to 9 into 10 to the power 9 Newton. Give it a equation number 1. Let us calculate force between same two charges under similar conditions in CGS system. So what will be? It will be F dash is equal to 1 by K Q1 Q2 divided by R square. For we know that in CGS system, this one is we are doing for CGS system. For CGS system in free space, we have the value of K is equal to 1, isn't it? So F dash will be Q1 Q2 divided by R square. We have taken that 1 coulomb is equal to x start coulomb. So what will the value of q1 and q2 becomes? F dash is equal to x into x, that is start coulomb, divided by 1 meter. 1 meter is 10 to the power 2 centimeter square. Okay, so it will become x square divided by 10 to the power 4, and the unit of force in CGS is die, and F dash is equal to x square divided by 10 to the power 4 die. Name it as equation number 2. Okay, so from our assumption or from our concept f dash is equal to f, that implies x square divided by 10 to the power 4 is equal to 9 into 10 to the power 9. That implies x square is equal to 9 into 10 to the power, sorry, uh, okay, okay, here I have done with dyne. If I will have to convert it into Newton, what I will have to do? I will have to divide it with 10 to the power 7, 10 to the power 5, because 1 Newton is 10 to the power 5 dyne. So it will become x square divided by 10 to the power 9 Newton. Okay. And what I will have to do here? I will have to just write x square into 10 to the power divided by 10 to the power 9 Newton. So Newton in both sides it cancel out, 10 to the power 18. That implies x 3 into 10 to the power 9, x is equal to 3 into 10 to the power 9. अतएव 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 1 coulomb is equal to 3 into 10 to the power 9 start coulomb. Hope you all understood the derivation, how we derive sorry, this relation between your between your coulomb and start coulomb. Okay.